Okay, so in this video, we will be discussing first order linear differential equations. Okay, so for the solution of first order linear differential equations, we will first transform the differential equation into a standard form. So where dy over dx plus p of x y is equal to q of x. Okay, so where p of x and q of x are both functions of x. Okay, so for our solution, so all we need to do is follow this formula. Vy is equal to the integral of v qx dx, where v is an integrating factor and it is equal to e raised to the integral of p of x dx. Okay, so say for example, so find the general solution of x to the fifth plus 3y dx minus x dy is equal to 0. So again, in finding the solution of a differential equation, so first we must select which method would apply. So far we have discussed three solutions for differential equations. So first, you need to try if it is variable separable. The next, you need to um, if it's not a variable separable, then you need to test if it is homogeneous. If it's not homogeneous, then you can try exact differential equation, and if not, so the next test that you will do is see if it's a first order linear differential equation. Okay, so by transforming it into its standard form, so dy over dx plus p of xy is equal to q of x. So now for our given example, so this is not variable separable, this is not homogeneous, and also this is not exact. So the next is we try if it is a first order linear differential equation. Okay, so transforming into its standard form dy over dx. So we need to divide both sides with x and dx to eliminate to have a denominator of dx and to eliminate x as the coefficient of dy over dx. So dividing both sides by x dx, and the other side divide it also by x dx. Okay, so we can cancel out dx here, and then x to the fifth divided by x, so we will have x to the fourth plus 3y divided by x, so we will have 3y over x minus x dy divided by x dx, so we'll have dy over dx, okay, is equal to 0. Okay, so we can transpose dy over dx on the other side, okay, and also 3y over x, so we will have x to the fourth is equal to dy over dx minus 3y over x. Okay, or if we switch them, so we will have dy over dx minus 3 over x y is equal to x to the power of 4. Okay, so this is now in standard form. Okay, as you can see, the coefficient of y should only be function of x. Okay, so our p of x is 3 over x, and that on the left side, or sorry, on the right side of the equation, it's only function of x. Okay, so only function of x on the right side. Okay, so therefore this is linear. Okay, so this is linear, and I believe you already know how to test for linearity. So where our p of x is negative 3 over x, okay, and our q of x is equal to x to the power of 4. Okay, so now using the formula vy is equal to integral of v times q of x dx, we need first to solve for the integrating factor before we can integrate the right side of this equation. So solving for v, so v now is equal to e raised to the integral of p of x dx. Okay, so this is equal to e raised to the integral of p of x is negative 3 over x dx. Okay, so negative 3 is a constant, so therefore we can take that out of the integral sign. So v is equal to e raised to negative 3 integral of dx over x. Okay, so therefore v is equal to e raised to negative 3 ln of x. Okay, or e raised to ln of x raised to negative 3. Okay, so therefore if we simplify, if v is equal to e raised to ln of x to the negative 3, then taking the natural logarithm of both sides, ln of v is equal to ln of e raised to ln of x to the negative 3. Okay, so therefore we can transfer the exponent of e on the coefficient. So ln of v is equal to ln of x to the negative 3 times ln of e. Okay, so but we know that ln of e is equal to 1, so therefore ln of v is equal to ln of x to the negative 3. So therefore, since ln of v is equal to ln of x raised to negative 3, then v must be equal to x to the negative 3. Okay, so using now the formula, so the formula for a linear differential equation is vy is equal to the integral of v times q of x dx. So v now is x to the negative 3 times y is equal to integral of v again is x to the negative 3. Q of x, as we have identified earlier, is x to the power of 4. Okay, dx. So therefore, we will have x raised to negative 3, y is equal to integral of x dx. Okay, so simplifying, x to the negative 3 times x to the power of 4, so that is x. So we can simply integrate this. So we'll have x raised to the negative 3, y is equal to 1 half x squared plus c. Okay, so we can have this one, or we can, if we want positive coefficients only, so we will have y over x cubed is equal to 1 half x squared plus c. So cross multiplying x cubed on the other side, so we will have y is equal to x cubed times 1 half x squared plus c, or y is equal to 1 half x to the 5th plus cx plus cx cubed. Okay, so it's very simple. So all we need to do is follow this follow this formula. Okay. So in this problem, so it's the integration was easy. Okay, this part. So because it's only power formula, but there are some other cases where you need to apply all that you have learned in integral calculus as well. Okay, so the most common are uh, right here. You will be required to use integration by parts, substitution. Okay, so any other method that will solve this integral. Okay, so that's it, and good luck with your assignments.